Part C in this section. Hey, it's high time that we saw some powers of secant and tangent. So let's go for secant to the third theta over 2 times tangent to the third theta over 2 d theta. Okay, so looking at the guide, which one, which situation are we in? Now, when it comes to secant and tangent, the options, right, there's different options than with sine and cosine just due to the nature of u substitutions and the derivatives of secant and the derivative of tangent. So as we look down the list, let's see, n is even, so that would be the power of secant is even, would be number one. Well, no, we don't have that. We have an odd power of secant. How about number two? M is odd. Yeah, we have an odd power of tangent, and n is greater than or equal to 1. Okay, that's what we've got. An odd power of tangent and at least one power of secant. So what are we going to do there? We're going to separate one of the secants and one of the tangents off on the end. And then I say same as previous, referring to the method for number one. We're going to use the identity 1 plus tangent squared x equals secant squared x, and then go for a u sub. Now, obviously, when you're doing these integrals, having this guide, I think, is really helpful. But I want you not to just be blindly following the guide once you've been doing these, but understand why you're doing what along the way. And really, the idea is we're just trying to set ourselves up for a u substitution. And so here, by separating a secant and a tangent, we're thinking, okay, eventually our du is going to be secant theta over 2 tangent theta over 2. Well, then what must have been the u? Now, what gives a derivative of secant tangent? And of course, it's the derivative of secant. And then we'll use the identity to put us in a position where we can take u to be secant theta over 2. Okay, so let's see it play out. We're going to separate one secant and one tangent, so leaving a square and a square. And now we're thinking, okay, we're setting ourselves up for a u sub, so this is going to be the du. So we need u to be the secant. Okay, so that means I'm going to leave my secant, and I need to change the remaining tangents into secants. And that's where the identity comes in. All right, 1 plus tangent squared x equals secant squared x. And so what's going to happen? Okay, well, I can just subtract the 1, and that's going to go right in. It is tangent squared. And I arrive at this. Certainly no small amount to be writing down, so maybe copy that and then just kind of look back at what we did. So, right, subtracting the 1, so we got secant squared theta over 2 minus 1. All the other parts are just copied down. Okay. Kind of nice about, lecture videos, right? You can pause, go back and listen to me again. So what's next? Let's do our u sub. U is secant theta over 2, which would mean du. Well, we got the secant tangent, but of course the chain rule on the theta over 2 would give us the 1/2 here. So 1/2 secant theta over 2 tangent theta over 2 d theta. And my style, I like to, hey, I don't see a 1/2 in there, so I'm just going to multiply that 2 on over to the left. 2 du is equal to what I see out here exactly. So at this point, very similar to that first example we did, right? We got u squared, u minus 1, and then 2 times du. And this all really simplifies down with that substitution for sure. Okay. from here, got to multiply it out, right? So I like to pull the 2 out in front. You could keep the 2 in there. I mean, whatever you want. And distributing u to the fourth minus u squared. Okay, antiderivatives. 2/5 u to the fifth. And let's just put that 2 back over. Minus 2/3 u to the third plus c. And of course, remember to put your u back in for the final answer. 2/5 secant to the fifth theta over 2 minus 2/3 secant to the third theta over 2 plus c. All right. Now, to end this section, this will be our last example. I want to give you something that, seems innocent enough, but turns out to be very nasty. That happens, it happens once in a while in this section. Truth be told, all of these integral sections have that element to it, that you see a lot of problems just, they're set up well. It's pretty clear. Once you get the hang of it, they're kind of just your basic problems or even your moderate level problems. And they tend to unfold once you get your head wrapped around the concept. They unfold fairly smooth. But then there'll be those problems that are just on a whole other level, and they don't seem to fit any of the typical approach. And you just like, what do we do with this? And you kind of start, really the idea is you kind of just have to start experimenting with different approaches until you get something that clicks. So let's see what happens with the integral of tangent to the fourth x dx. Okay, so as we look at our list of options there for powers of secant and tangent, so it's clearly, it's not going to be number 1. N is even. So you could argue here, hey, isn't the power of secant even? It's like a power of 0. Well, that is true. You could say certainly that the power of secant here is even, but then, what did the directions say? Separate secant squared x. Well, it's hard to separate a secant squared when there aren't any to begin with. Okay. So we're not going to use number 1. Is it number 2? Well, no, because the power of tangent is 4, right? It's not odd, obviously. And we don't even have one power of secant anyway, so neither of those hold. Okay, so we got to go with the other. So when I list the other, these are like the top 3 other ways to approach an integral if it just doesn't fit the rest. Okay, so you see my 3 approaches. That's not to say these are the only 3 approaches. These are just the more common ones. Okay. So looking at that, excuse me, I had to sneeze there. I knew it was coming. Okay, so looking at those list of 3, what might we do? And so you see, okay, well, maybe there's still a way that we could rewrite with the trig identity. Possible. And then it says split the integral. Okay, that's interesting. So maybe once it's rewritten, then we we break the integral in 2, and then maybe one we can do immediately, and the other we have to work with more. You might have to fall back to integration by parts. Sure, why not? It might use a method from the previous section. And then the last one, I tend to think of that as like the nuclear option. I have no idea what to do with this, so let's just convert everything to sine and cosine, and maybe we can simplify it down and see it a little bit more plainly, and maybe a u sub would be more obvious if everything was written as sine and cosine. Okay. So I'll tell you, that's not what we're going to do here. We're not going to rewrite this with sine and cosine, although it wouldn't be wrong to experiment with that and see if you could get anywhere. That's not what we're going to do. And it's not going to be integration by parts. Actually, this one, we're going to still use the identity, and we're going to end up splitting the integral. So let's see how that works. So I've got a tangent there, so we're going to end up rewriting it with secant, and it's going to go a little something like this. Now, this one is especially nasty. You don't want to rewrite the entire tangent to the fourth. And that seems like maybe that's what you should do. But if you rewrite the entire tangent to the fourth as maybe, say, secant squared x minus 1 quantity squared, well, you're not in any better position than you would have been just with tangent to the fourth x, because if you've got a secant squared squared, you still have a fourth power. And kind of part of the goal is, maybe if we can make those powers smaller, or at least put them in a situation where we can do a u sub, and just converting everything to secant, it would actually just make it worse. So instead, and this is just kind of part of the real sneakiness behind this problem, is splitting it as tangent squared x times tangent squared x, and then just converting one of these. I'm going to think of the second one with that identity. Now, who would think to do this? I agree, but that's just the result of a lot of trial and error. Okay, so what we're going to do is convert that second one to secant squared x minus 1. And now we've got a square of tangent and a square of secant. So at least we've got something different than what we started with, and certainly not worse. Okay, at this point, and again, it's not obvious, but it's just what we need to do here. We're going to distribute that tangent squared x, and we're going to split the integral. Okay, so if I distribute tangent squared x here, and then think of that as the first integral, and then over here, and that's the second. Now, how is this beneficial? Hey, what just happened with this first integral? Are we going to be able to do this? Don't we have an even power of secant? Okay, yes. So just rearranging things, now we have an even power of secant. That's great. Still, this one, though, not so sure about what to do there. Okay, well, let's see what unfolds next. Oh, what just happened? I did not see this coming. We've got the even power of secant, and so you would think, oh, okay, I see what's going on. Since it's only a second power of secant, the directions say separate secant squared. Well, we don't need to separate it because it was already good to go. It was already a secant squared. And we don't even need to use an identity because the other parts don't involve any other secants because we didn't leave any behind. So we can just go straight for our u sub. We'll take u to be tangent, and there's our du right there, thinking of that as been separated, and that's going to work perfectly for us. Okay. And so here we see that, okay, it's just going to be a u squared du. No problem. We got it. Now what happens over here? Well, again, I have an even power of tangent, right? Which is exactly what we had in the original problem. Except now we took it from a fourth power down to a square. Well, maybe if we do the same approach again, it will get even better. So we're going to replace this with secant squared x minus 1, which is what we did, right? What we did with this tangent squared, we're doing that a second time. Okay. And now we got it all. 1/3 u to the third antiderivative of secant squared is tangent x, and then those negatives would give us the plus x plus c. Replace your u, and there you got it. 1/3 tangent to the third x minus tangent x plus c. Now, a problem like this, again, this is not obvious. This is very challenging. And it could even be that somehow somebody thinks to, think of it as tangent squared, and then turn just one of them, maybe even to multiply it all out, and then they get stuck on what to do with that, right? Well, hey, I took a tangent squared earlier, it worked, I made some progress, let's do the same thing again. And, it's now a simpler version because we don't have to do with the u sub. Um, and there you go. Okay, that's the end of this section. I guess the only thing left I can say, down at the bottom of the integral guide, you see if you are presented with an integral that maybe has sines and cosines with different angles. And so the example I give there is sine 5x times sine 2x. You'll use those whichever of those three formulas fits, so that you will wind up with, instead of a product of two trig functions, the addition or subtraction of two trig functions, and you can easily get an integral from there. So I'm not going to do any examples like those. I think those are much more straightforward, especially after having done these more difficult ones. So best of luck to you. Bring your questions to office hours, and hopefully I'll see some of you guys there.